Welcome back to Logical Thinking, and today we're going to be talking about propositions. I like to think of propositions as the basic building blocks of logic because these are the things that we assign truth values to, which in logic is often what we're interested in. And propositions are simply statements or things that are truth evaluatable, meaning they refer to things that are either true or false. Now, you may see some logicians or people that study logic use other words like sentences or statements to refer to what I call propositions, but I'm going to stick with the word proposition because I like to use proposition to refer to something made of concepts that is truth evaluatable, whereas the word sentence to me often refers to a linguistic arrangement of words which may or may not be a proposition. And this distinction between propositions and sentences is important because propositions primarily refer to ideas and concepts and thus are independent of the language used, at least as much as possible. So me saying, I am hungry and tengo hambre refer to the same proposition or the same idea, despite the fact that these sentences and even the languages used are different. So the point of using propositions is to focus on what we care about, which is the truth or falsity of the ideas in question, and not the words or language which can just add extra fluff or confusion to these ideas. Now, good examples of propositions are things like claims, such as the claim that Millennium Force is 300 feet tall, which is true, or the claim that I am a billionaire, which is unfortunately false. And note that these propositions refer to concepts, so the idea that you are hungry could refer to different propositions depending on who you are, the subject. And we would need to know this either beforehand or from the context to understand exactly which proposition that refers to. So what you'll find is logicians often try to be really precise or really clear about it to avoid any sort of confusion on this matter. And what may be helpful is to see some things that are not propositions. And the first class are things like expressions or explicatives like crap. This is just kind of an utterance. It doesn't really evaluate to true or false. Another set of things that aren't propositions are imperatives, so me commanding you, like do your homework. This isn't a proposition because it doesn't evaluate to true or false. And lastly, questions. Questions are something that don't evaluate to true or false either. It may be true that I am hungry, but a question is something that invites an answer and not something that can be assessed for its truth or falsity without really knowing the answer in question. In other words, the difference between the proposition, you are hungry, and the question, are you hungry, is we can assign a truth value to the proposition, you are hungry, whereas to the question, we can't. What you'll often see us do is we'll assign letters to stand in or substitute for propositions, just like letters can stand for numbers in algebra. And the nice thing about this is it allows us to separate the relationship of different propositions with what the content actually is. And this will make sense later when we start talking about the relationship between different propositions. What this will allow us to do is understand if an argument is valid outside or independent of the actual propositions used. And you'll see that there's some arguments that are wrong, not because the premises are wrong, but because there's no way the conclusion could follow from the premises by the structure itself. So there's a difference between the structure of an argument and the content of it, and often in logic, the structure is perhaps just as important. These variables allow us to substitute in actual propositions which can stand in for letters in these different structures, and often we'll use just a single letter to refer to a proposition. For example, if I say P is the proposition, I will go to Cedar Point this year, I can simply assert P to stand in for that proposition whenever I want it to. And we'll often say that somebody asserts a proposition by just simply saying P. So claiming P or making a proposition is really making a truth claim. And for the sake of simplicity here, I'm going to be assuming the T schema or truth schema. And if you haven't heard of this, don't worry about it at this point. But basically this means asserting a proposition P is the same as asserting the proposition P is true. So, just saying P, like I will go to Cedar Point this year, is the same as me saying it is true that I will go to Cedar Point this year. And this comes from ideas from the mathematician and logician Alfred Tarski. It's a really common assumption, and it just makes things easy because, in my view, it just keeps the focus on the truth claims in question and not the semantics. So when you see phrases like P in an argument, this is interchangeable with saying, P is true, that an assertion like that. So but often we'll just say, just write P, but just know in your head that that's basically saying P is true. It's making that particular claim. And as a result, one easy way you can test if a sentence is a proposition or not is to see if its meaning is clear or still clear if you add it is true that or it is false that in front of it. Sometimes English can get a little bit confusing, so this is one way that helps us see. So consider the sentence, for instance, you are hungry. It kind of sounds like a command, may not be clear whether or not this is a proposition, but if we add it is true that you are hungry or it is false that you are hungry, we now have a statement which seems to pretty clearly be true or false. However, if we add this to a question like, are you hungry? We still kind of have what I would call an open question. it is true, are you hungry? This doesn't really make a lot of sense. If we take, the proposition, clean your room, and we say, it is false, clean your room, this declaration doesn't really express an idea that is true or false. So once again, this is an easy way to tell whether something is a proposition or not, but often we want to be really, really clear, and you'll often see logicians try to be very clear about this. Now, when you actually move to digital logic, propositions are analogous to digital signals which have either a high or a low voltage. And computers or any other type of digital logic, they're built out of switches or transistors which either pass current/voltage or not. And digital signals inside your computer are stored in transistors corresponding to things like, say, you have mail, or somebody pressed the escape key on the keyboard, or the player pulled the trigger on their PlayStation controller, something like this. And in digital logic, signals are either on or off, just like propositions are either true or false. And other names you'll often see for the word true include the number 1, 3.3 volts or 5 volts, which are standard voltages for things switched on in digital logic. And other names for false are the number 0, 0 volts, low, or off. And what you'll often see too is most programming languages actually include words that refer to these concepts. So Python, C, and Java have what are called Boolean variables after the logician George Boole, which are represented by the words true and false. By breaking these things down by concepts really down into things that are either true or false, we can store the state of different things in things called bits, which are either 0 or 1. And this is where the word binary comes from. Bi meaning two, or two-state logic. This two states being true or false, or maybe 0 or 1. It doesn't really matter what they are, it just matters that you have two different states. In fact, the word bit, referring to a single 0 or 1, is a way of combining the word binary digit to a single word. And think about the fact, reflect on this, that you're watching this video, which is actually encoded and presented to you as a sequence of ones and zeros, of trues and falses, being sent in different ways through your computer or phone and around the internet. And in later videos, we'll talk about combining propositions in ways that allow us to build up more complex statements out of a few simple rules. The whole point of talking about logic is laying the foundation that will help us build more complex things out of just a few simple building blocks. This is the idea behind abstraction. So thanks for watching, and I'll see you in the next video where we'll talk about logical connectives and truth tables.